As an engineer, oftentimes when I think about trying to solve what I conceive to be problems in your system, I think what I generally get is what would be best considered as a snapshot. So it's either a clinician coming up to me and saying, "Here's the problem," me coming down to the hospital saying, "This is what I think the problem is," and then I go off in my lab and I try to develop what I think is a solution for this problem, only to come back and realize either A, I didn't fully understand what the problem was, or two, kind of given the dynamic nature of the healthcare system, I've only seen one occurrence of it, and the problem is actually we've talked about being very multifaceted, and that has actually changed in some way. So how do we kind of close this loop so that we can start iterating on, coming up with technologies to solve these problems in a more efficient manner? And then I guess the second part of that is how do we make sure that we end up in really having real world impact, so actually getting to, let's say, the bedside of the patient?
Well, so I think the key feature that has to come into play is that we have to have engineers being vetted with clinicians, right? So what you described is the classic problem of not enough communication. So you said, I come, they tell me a problem, I go back, I work on my solution, I come back and realize it's the solution to the wrong problem. So instead, what we really need is for engineers to be part of the process, part of the workflow, part of the team. And when you've got a problem you have to tackle it, you need to go see some of those facets, and you need to also find people to work with from the clinical side who can think a little bit like an engineer rather than like a clinician, talk to you a little bit like an engineer might talk to you. And there are people like that around, or clinicians who, play engineers on TV.
Yeah, I would just add to that that it's certainly an iterative process. Use the right word. We definitely iterate. A lot of it really does come down to communication. As you said, I don't think that there's a day that goes by where I don't meet with at least one of my clinical collaborators. We rely on them to make sure that we're answering the right kinds of questions. To give you an example from my own work, CDIF. So my students went off, they had all these data, they sorted them so that we had the causal ordering, made sure we were predicting, and they came into my office and they had an AUC of 0.99. I said, we solved C. diff. I said, I don't think so. And we looked at what the model had learned, because what was being transparent model. And one of the variables that was most predictive was the receipt of oral vancomycin, which, not being clinicians, didn't realize that was a treatment. It's used only for C. diff. So even though we respected the causal ordering, we didn't realize that this treatment was often given empirically before the test results came back. So we were just picking up a signal that physicians had suspected C. diff. But those sorts of realizations don't come across without that communication and that iteration.
I think I agree with all that. I think it's important to keep in mind as well that it's not just you're not just working at solutions for the future, but the collaboration is important for now. So, for instance, partner a lot together with other folks at the Malone agency around robotics, and on a recently to observe the operating room, and this was in preparation for some studies that we're doing in machine automated coaching and learning robotics. But he also has other tips and insight in terms of the setup, clinical and from standpoint. So it's just reflective, I think, that in this, as well as in other areas of diversity, groups, diversity of thought, and collaboration is really important.
Yeah, I as an engineer, I'll say that it's very challenging to work with. One aspect is just being able to seek out and identify clinicians who can work. Many are, in many cases, the spirit is willing, the flesh is weak. By the time I get to the clinician, He says, look, it's 10 o'clock at night. I'm sitting on the couch. I just don't want to work on a proposal. So they're busy folks, and it can be a struggle. I end up writing the CVs, the bio sketches for some of these guys. I've sat down in a clinician's office at 7 a.m. and said, okay, what are your contributions to science? And he said, well, I don't know. And I said, well, let me suggest a few. You just raise your hand. And these are great folks, and we end up getting things done. They're busy people too. So I don't know that they always are incentivized enough to put in time on it. I do think that once you find that collaborator, working on a proposal together, well, I hate to say it, nobody likes to write proposals, but there's a lot of benefit in that because you have to refine your ideas. It's not just going once and saying, I think this is cool. You really have to refine it and come up with a plan that you can get by a review. And so that, I think, helps refine things too, but it's tough.
Hi, my question is for Dr. Wines. Thank you for your interesting talk. I think a lot of times in engineering, we want to build a model that works for everyone everywhere, but you talk about how training a model for individual hospitals is helpful. Do you think that's because the type of information and maybe the bias of the population you're seeing are different at hospitals, or maybe the way the nurses are visiting patients and the sheets are cleaned, maybe C. diff is spreading in different ways at different hospitals? So just curious.
Yeah, so that's a great question. I think that there are a number of different factors that contribute. One is, like you said, even just the hospital layout is going to differ, right? So by trying to find this one-size-fits-all model, you might be ignoring that hospital layout or how those hospital-specific factors might play a role. The other is just from a labor perspective, right? How labor-intensive it is to find that one-size-fits-all model because you'd have to have a mapping, right? So even if I thought I could get more power out of pooling all the data together from Michigan and MGH, trying to find variable X at Michigan and find the same variable at MGH requires, it's error prone and labor intensive, right? So it's not even clear that that's the best approach clinically or the best approach technically.
Thanks, Zoe. First, great presentation. I think it's just exactly appropriate this intersection for engineering and healthcare. The topic you presented, I get. But I was curious about a couple of different things that maybe David start with you. So I thought you had just an incredibly nicely structured presentation about how we should really find high-impact problems and then identify solutions that address them. But when you're coming to it again from an engineering perspective, typically it's kind of a game of one-offs. Kind of alluded to this earlier, right? You find a clinician to talk to, and they typically have their favorite problem, which to them is actually a very important problem. Probably is an important problem, but it may not be the highest impact problem. And so I'm curious if you have ideas for how one would surface these high impact problems, and how do you generate consensus around them from the healthcare side of the equation?
Yeah, it's a great question. So I guess I'll start with the fact that we work with engineers all the time in the Neurovisual Vestibular Disorders Unit. We have engineers embedded in our iMove lab. So we already established these sort of long-term relationships with people to deal with engineering aspects that are related to us. So they're not necessarily playing the same consultative engineering role that we do. Okay, now do this project, and maybe the next one, and the next one. I guess what I would encourage all the engineers in the audience to do is to spend a little bit of time, rather than just taking the first clinician that walks by who seems friendly enough to say hello, and then saying, what are you interested in? That maybe they should take a moment to think about the public health landscape, what kinds of solutions they're trying to bring to the table and where they might be best applied. And actually have some exploratory conversations with people in those domains. Try to get a feel for what's the epidemiology of these problems and where's the potential for improvement. how many lives and how many dollars are we talking about before they pick apart in that sphere? That's the only solution I can think of that would get them, I think, to where everybody wants to be, which is the biggest public health impact possible.
Hi, I wanted to give some assistance with the questions. I'm the Director of Nursing in the Emergency Department here, and we work with Dr. Newman-Toker on teledizzy. So we know it's a challenge to engage clinical staff, and that's what I'm hearing a lot, is how to get in the door. Use your nurse managers. They know who in nursing is looking to advance, who has interests in different things. Maybe you have people interested in strokes. In the emergency department, we also use machine-based e-triage, and so our nurses are becoming familiar with that. And then our clinical nurse assistants also do telemedicine. They do telescreening. So that's the group that we're tapping into. Right now, our teledizzy consults are only 8 to 5, Monday through Friday. So what we're looking at starting in January is training our staff who are already familiar with the telemedicine equipment on doing, assisting with the teledizzy consults 5 to 11, Monday through Friday. Because while we started in July, we've had about 50-some patients, and now we're collecting the data. What the staff really want to know, and as an engineer think about this, is what, number one, is it going to make my work harder? Because we don't want to do that. They're already busy. Every clinician is running around. So they've got to be able to put together that this patient who came in and has dizzy symptoms now doesn't need to have this long length of stay. They're actually seeing it happen. So if you have the patient come in and get the consult, bring in all your staff at once to say, look, this patient had a 3-hour length of stay. They didn't need a CAT scan. They didn't need an MRI. So we really want to try to engage while things are happening. We're always happy in the emergency department to help. Look at your informatics nurses too. That's a big pool. Stephanie Poe's group for the whole health system. That's the people that want to help you, that want to understand how to bring technology in, and then also how it can obviously benefit the patients, but the staff want to learn too.
Yeah, just to drive home that point, you can't do anything at the implementation level without local champions who are going to step up to the plate and be willing to embrace change in a positive direction for patients in the healthcare system. So you got to find those people. That's not always easy, on day one. You don't just sort of necessarily pop right out of the woodwork. But if you go spend time, do the work, sooner or later you figure out who people are supported. Just lean on those people to help you, because you're not going to be able to implement anything from as an outsider. Even I'm an outsider. I'm a clinician, but I'm an outsider in this department. So I've done all my research in forensic my entire life, and spent years during my neurology residency being an ER neurologist. So you've always got to find people working within the system to be your champions. You shouldn't underestimate how important that is.
Actually, I want to follow up on that. That was my other question. I was going to ask Jenna this because you are coming from as an outsider. So the other side of the, identifying the problem is actually getting it used. So there's this term implementation science that cropping up more and more about translating from something that works in the lab to something that actually works on the floor. I wonder if you could talk a little bit about what was your evolution in terms of taking basic machine learning results and actually getting them used in the hospital.
We're still working on it. That's my experience right now. I think that a lot of it was very educational because I realized that it wasn't enough to just take my machine learning solution, throw it over the fence, and patient lives would start being saved. I really had to go back to the drawing board and think more carefully about the question I was trying to answer and how we were trying to answer it. And I'm very, very fortunate to have wonderful collaborators at the University of Michigan who really are the local champions and are working with me. So I'm working right now with the antimicrobial stewardship team at the University of Michigan to see what's actionable in the model. So in terms of identifying patients at highest risk, are they all on unnecessary antibiotics that we could then but it's really, team-based. I can't do it all. I rely on those people. So that's been my experience so far. And it's been a lot of fun, too.
I'll also just mention that there are times where, what was discussed this morning is so critical, this sort of larger work system and the fact that you can have unintended consequences of making a change in the system. For instance, we're discussing now what's the next hospital within the Johns Hopkins Health System. Are we going to extend this television program? So, okay, look, we can get it up and running at Johns Hopkins Hospital, but what's next on that? And we had a conversation with one of our hospitals where they said, look, this is great, but we have an existing relationship with NIH, and we have this whole imaging program, and if you come in and you decrease unnecessary imaging, and you're doing this other stuff, this is going to rock our relationship with this other place. And so these are the realities, right, that are part of that discussion. It's not just, yeah, this is good for patients and let's just go. Those things are good for patients too, right? And we're potentially at two competing improvement programs. They've got one that's trying to get stroke patients faster, quicker treatments through immediate neuroimaging. We've got a separate one that's trying to make sure that some people don't get missed and the other people don't get unnecessary imaging, and they may be competing with one another. And that system dynamic is its own problem.
I'd actually like to build upon that a little bit. That was actually one of the other questions I was thinking about, and thinking back to what Dr. Perry mentioned in her talk this morning, kind of this idea that, let's say I design a visual display. Patient, I can come up with the best visual display, but if I put it in front of the sink, I'm actually inhibiting something that's very critical to patient safety and care. And so how do we, as, let's say, individuals that think of technology also try to come up with or try and evaluate what trade-offs are? So, I think, Gita, you mentioned, what some of the benefits of technology in the invasive space, but also maybe what some of the drawbacks could be. Pierre, you talked about how the benefit of the robots may actually not even be there in some situations because it may be you're trying to solve it with technology, imaging. And so I'm just wondering, how do you all think about the entire spectrum of your approach, the trade-off effects that it will have? You can create a nice robot, but if it takes 3 hours to set up, it may not be that beneficial to the patient.
I think it's ongoing study and examination of what you're trying to utilize. For instance, the robotic surgery really took off in general surgery, and there's been little data to support its use in terms of patient benefit. There's certain pockets where we're starting to see that now, but there's a lot of marketing behind employing this and for incentives for hospitals and clinicians to use it. Which comes at a great healthcare cost. And so I think we have to be very cautious about this and where we're going to employ it when you look at the broader public health initiatives and where these healthcare dollars ought to be spent. And I think a lot of this really just has to do with ongoing outcomes tracking, as well as study of what you're actually doing, make sure it makes sense and that the value is there for this new technology.
I would agree. I think I've spent a good portion of my career working in medical robotics, trying to solve the problem of medicine. And I think it's, people love the idea of rock platforms that apply to many conditions. But my sense is that the real solution would be very specific, tailored to different different treatments. But I think there's a future there, and it's going to be a matter of finding it, and probably taking simpler steps, solving simpler steps first in terms of, for example, catheter navigation, just automating portions of that, bringing it back to where we were when you have to pull the system out. So those simple steps, I think, will teach us a lot about what the more robust mechanisms will be. Now we're going to have our fifth panel speaker ask a question.
Yeah, I just wanted to get you. I was actually going to comment on that. I think the trade-off. We we often in these panels downplay the general platforms and say, well, I can have a special device for this, for that, and the other, and the other. If I look at a DaVinci, if I look at everything it does, that's a very large number of special purpose devices that you have to implement, put into a hospital. If you look at even their specialized data vectors, where they have this enormous library of those, they're all enabled to be developed because there is a general platform so that you can customize it by adding technology in a cost-efficient manner. So I think the trade-off is more complicated than often these panels indicate. You're right. Building the humanoid or the robot that can do everything that a surgeon can do is also going to be very expensive and probably not very practical. But I actually think this is something that we need to understand better, the interface between generalized platforms and custom technology. And perhaps people would want to comment on that.
I think that I can't really speak from an engineering standpoint. From a clinician standpoint, having a generalized platform does make sense. And what I was talking about was more about the clinical application of robotic surgery. But for instance, so with the DaVinci, there's the different models, and some specialties really make sense to have an SI model. But for general surgery, the XI is better, and now there's going to be a single port platform. And at some point, when you look at the value of these, it makes more sense to have a generalized platform, which then you can adapt for specialty. But there's going to be specific applications of that or tools that make sense for one specialty versus another. And, and how do you develop that on a broader scale? Or there's just going to be some people that lose out. For me, as like a small-handed surgeon, a lot of these things that I showed were developed for like a size 8+, and I wear like a size 6 barely. And so I have to adapt to that, and we're having to do the same thing on a broader scale.
Yeah, I just to add to that, I think one of the things that we need to look at with these general platforms is how to integrate them both with discrete devices and very broadly with the imaging and other information infrastructure. And I think this is potentially an area of great value where a relatively small increment of effort can produce a big increment in usefulness. But we have to work with the physicians to figure out which of those things we should be working on now.
Yeah, I just wanted to add that Russ and I have a long history of many debates on the topic. But you know what I wanted to point out and mention is that while we come at things from completely different angles sometimes, I think that's part of the richness of what we bring to the effort. If we all did everything in exactly the same way, then we'd have a government-run program. As opposed to more of the entrepreneurial spirit, which is more likely to lead to advances. So I applaud this platform.
Yeah, just quickly, I assume that the DaVinci robot is not going to diagnose anybody's dizziness anytime soon. And although I think it's a little bit of a false dichotomy, as I think you guys are talking about, in the sense that all of these things we want to find specific solutions that fit within a generalizable framework that allow us to sort of tackle one thing at a time. And decision support is clearly going to be one of those things on the cognitive side in terms of supporting people's diagnostic decision making. For instance, it's unlikely that we're going to get a one Delphic Oracle tool. They tried that in the 1980s and into the early 90s and it sort of failed miserably. What we're going to get is a bunch of apps that are part of an operating system and a platform that allow us to each tackle our own problems that we
Well, with that, I think we're going to have to wrap up so we can move on to, I believe it's the break for our next session. But before we get there, I want to once again thank our panelists for presenting.